In this video, we're going to talk about rates of change. Now, the rate of change of a linear function, f of x equals mx plus b, is just the slope m. Okay, now let's look at an example. Consider the function f of x equals 3x plus 5. Well, according to the definition, the rate of change is 3. Okay, it's the slope m. Now, why do we call that the rate of change? Well, notice that if we make a table of values for this function, put x in this column and f of x in this column, and we pick some values of x. I've picked 1, 2, 3, 4, and 5. Notice that the value of f of x changes by 3 every time. It goes up by 3 every time. As x goes up by 1, f of x goes up by 3. So we say the rate of change of f of x is 3. Okay, and that also happens to be the slope of the function. Okay, now the value of a computer or an automobile or a machine depreciates, or it decreases over time. Okay, so if you buy a computer right now for a certain amount of money, a couple years from now that computer is not going to be worth as much as when you first bought it. Okay, the same thing with a car or a machine. It depreciates in value. Now, linear depreciation means that the value of the item at time x is given by a linear function, f of x equals mx plus b. And the slope m of this line gives the rate of depreciation. Okay, let's look at an example. According to Kelley Blue Book, a Ford Mustang two-door convertible that is worth $14,776 today will be worth $10,600 in 2 years. Okay, if it is in excellent condition with average mileage. Now, assuming linear depreciation, find the depreciation function for this car. Now, before we begin this, let me just say that linear depreciation is not really realistic in this situation. The value of a car goes down most quickly in the first few years of the life of the car. Okay, and then over time, the value of the car keeps going down, but it goes down a little bit more slowly. Okay, so linear depreciation is not really realistic in this situation, although to make the problem simpler, we're just going to assume linear depreciation. Okay, now our function we're going to call f, okay, and we're looking for a function f of x equals mx plus b, because it's going to be a linear function. But one thing that we know about the function is that f of 0 is 14,776, because at time 0, okay, when the car is new, it's worth that much money. Okay, now after 2 years, the value of the car is $10,600, so f of 2 is equal to 10,600. Okay, now the question is, what is the m and what is the b? Now let's just do a real quick sketch of the graph of this function. We know that at time 0, it's going to be up here at 14,776, and then after 2 years, okay, it's going to be down here at $10,600. Okay, so these 2 points right here are going to be on the graph. Now it's going to be a straight line. Okay, it's a linear function. And so the question is, what is the equation of this line? Okay, what is the equation of this line? It should be f of x equals mx plus b, but what's the b? Well, we know the b. The b is the y-intercept. The b is 14,776. Okay, now what is the m? Okay, well, the m is the slope. Okay, it's rise over run. Now, you could figure out rise over run by calling this point 2, 10,600, x1, y1, and calling this point 0, 14,776, x2, y2. Okay, but let's just think of it in terms of rise over run. The run between these 2 points is 2. Okay, we're going from 0 over to 2, so the run is 2. The rise, well, actually the rise should be negative because we're going down as we go left to right. And it's really 10,600 minus 14,776. Okay, and that ends up being minus 4,176. Okay, so basically to get from this point over to this point, we go over 2 and down 4,176. And if we divide that by 2, we're going to get negative 2,088. Okay, so that is the slope of that line. Now notice it doesn't look like it's that steep, but the reason is because my scales are so different here. One tick mark here this distance is 1, whereas this distance is 10,600. So the graph looks a little bit off. But the slope is negative 2,088. So what we have is that f of x is equal to mx, so that's negative 2,088x, plus b. But b is 14,776. So this is the linear depreciation function. Okay, now the question in part B is what will the car be worth in 4 years? Okay, so you suppose you go over here to 4. Okay, what will the car be worth in 4 years? Okay, so what we really need to find is f of 4. Okay, so plug in 4 into this equation and see what we. Now, when you multiply negative 2088 by 4, you get negative 8,352. So you'd have to use a calculator maybe to see that. But then we're going to add 14,776. And when you do that, that ends up being 6,400 and let's see, what would it be? 24? I think that's right. 6,424. So what does that mean? That's $6,424. That is the value of the car after 4 years. Notice the car is going down in value. Initially, it's worth $14,776. Then 2 years later, it's $10,600. And then 2 years later, right, so after a total of 4 years, it is worth $6,424. Okay, and the question is, at what rate, the final question here is, at what rate is the car depreciating? Well, notice the rate of depreciation is the m. Okay, the m is negative 2,088. And actually, if we were to put units on this, that would be negative $2,088 per year. Okay, that's how much it's going down by per year. Okay, you could put a dollar sign here or just write dollars up there.